Today we would like to explore a quite simple yet interesting phenomenon, emptying rate of fluid containers. In 1643, the Italian scientist Evangelista Torricelli found that the velocity of the flow of a liquid through a small hole is the same as the velocity of a body, in this case a drop of water, which accelerates while free falling. Although Torricelli was right, his discovery is a specific case of a later developed equation known as Bernoulli's equation. Bernoulli's equation states that the higher the flow speed of a stream on a surface, the less pressure the stream will exert on the surface. Bernoulli's equation on the surface of the water at height h is: since it is assumed that the surface area of the container is much larger than the surface of the opening, it can be assumed that the speed of the surface drop is negligible. Bernoulli's equation at the opening of the liquid outlet is: since we defined h equals 0 at the hole, after comparing the expressions, we got a very interesting result. The speed depends only on the water level. Let's see it in action. We took a bottle, cut its upper part, and pierced a hole with a diameter of 2 millimeter. We inserted a straw into the hole and fixed it well. On a scale, we placed a large bucket into which the water from the tank will be emptied. We repeated the experiment 3 times, each time filling the tank with a different level of water. As you can see, the container with the largest H has the highest outflow speed. As we saw in the experiment, if we put the height h in the formula, the highest speed will be obtained for the highest h. After seeing the theory in action, let's try to challenge it. We took 3 bottles with different diameters and filled them with the same water height. You can see the outflow speed isn't equal as we anticipated. Why? While the equation for outflow speed at any instant doesn't explicitly include the tank's diameter, the diameter affects how quickly the water level h changes over time. What about the hole location? We can see that the location of the hole does affect the speed, but we can also see that except for the lowest hole, the bottles were not fully empty. Let's check the effect of the hole diameter on the outflow speed. We took 3 identical bottles and changed the hole diameter in each one. As you can see, also in this case, we didn't get the result we anticipated. Let's run it a little faster and explain why we got such behavior. Changing the diameter of the hole affects the outflow rate and the dynamics of how quickly the tank empties, even though the speed at which water exits the hole at any given moment is still governed by the height of the water column above it.